Today's lesson is on divisibility rules, and it's a review of the 6th grade number sense standard number 4, and our I can statement is I can use the divisibility rules. The materials you'll need for today's lesson are your red, orange, yellow, green, blue, and purple color pencil, your regular pencil, a pair of scissors, a glue stick, your math notebook, and the divisibility worksheets.
In this lesson, we are learning about divisibility rules. A number is divisible by another number if you can divide the two numbers and get a whole number answer. No decimals or fractional parts. It's what we typically call goes into it evenly. For example, 10 divided by 2 is 5. But 5 divided by 2 is 2.5, so it's not evenly divisible by 2. You can also skip count to figure out if numbers are divisible. If you skip count by 2 and you say a number, then that means that number is divisible by 2. But instead of doing a whole lot of skip counting, we can follow the divisibility rules to help us decide whether or not a number is divisible. This is pretty helpful when we are doing division and also in simplifying fractions. All right. For 2, to know if a number is divisible by 2, the number has to be an even number, which means the last digit in the number is either a 0, 2, 4, 6, or 8. Some examples of numbers that are divisible by 2 are 6,912. I know this is divisible by 2 because the last digit is a 2, which is in my rule. 14.6 is also divisible by 2 because even though I have a decimal number, the last digit is 6, which makes it divisible by 2. An example of a number not divisible by 2 would be an odd number like 493, and because it ends in an odd number, it is not divisible by 2. So this is an odd number. It's not divisible by 2, and I shortened divisible there. Now all of the numbers on this chart that are divisible by 2 are going to be colored in red. So anything that ends in a 2, a 4, a 6, an 8, or a 0 is divisible by 2, which means each of these columns will be colored in red. Remember, your coloring doesn't have to be perfect. Just try to do your very best. All right, let's talk about the rule for numbers that are divisible by 3. The sum of the digits is divisible by 3. By saying sum of the digits, that means that we have to add up the digits that are in the number and then make a decision. So I'm going to make myself a little table where one of the columns has number. I'm going to write the sum of my digits. And I'm going to abbreviate it to dig, and I'm going to put a check mark so I know whether or not it was divisible by 3. The first number we're going to test out is 51. The digits in 51 are 5 and 1. So to find the sum of those digits, I'm going to add 5 plus 1, and 5 plus 1 equals 6. And since 6 is divisible by 3, we know that this number is divisible by 3. The next number is 219. So this number has 3 digits, 2, 1, and 9. I will add all 3 of those, 2 plus 1 plus 9. I know that 9 plus 1 is 10, and 10 plus 2 is 12. And I know that 12 divided by 3 is 4, so this means that 219 is also divisible. I meant by 3. It's divisible by 3. The last number we're going to try out is 137. We have 3 digits, 1, plus 3 plus 7. I know that 7 plus 3 is 10, and 10 plus 1 is 11. 11 is not divisible by 3, so I know that 137 is also not divisible by 3. When you add up the sum of the digits, if that sum is divisible by 3, like 6 and 12, then we know the original number is also divisible by 3. In the last example, because 11 is not evenly divisible by 3, 137 is not. On our chart, we're going to color in all of the multiples of 3 between 1 and 50. This is where you can do the skip counting. So our first one would be 3. And then I would go 1, 2, 3, and 6 would be my next number. And I am using my orange color pencil. And that's the last one on this chart. Let's move on to the number rule for 5, which is one of the easiest ones. The last digit in the number has to be 0 or 5. Those are the only two choices. So one of the numbers we're going to look at is 4,980. I'm going to underline my last digit and check it against my rule. Is it a 0 or a 5? Yes, it is. That means that this number is divisible by 5. My next number is 5,655. Looking at my last digit in my number, it is a 5. Therefore, it goes with my rule, which means it is divisible by 5. For the 5s, we're going to use the yellow color pencil, and we know that the only numbers we can color in are ones that end in 5 or end in 0. So that's going to mean this whole column and this whole column. The next rule we're going to talk about is whether or not a number is divisible by 6. The number has to be divisible both by 2 and 3 to be divisible by 6. I'm going to make another table like I did for this divisibility rule of 3. So I'm going to do a number symbol, a 2, a 3, and a 6. Draw a line underneath. The first number we're going to decide about is 30. Thinking back to my rule for 2, I see the last digit of my number is a 0, and that makes it an even number, so that means that yes, this is divisible by 2. Looking back at my rule for 3, the sum of the digits is divisible by 3. My digits for this number are 3 and 0, so 3 plus 0 is 3, and that means it is divisible by 3. So for the decision for 6, it says for a number to be divisible by 6, the number has to be divisible by both 2 and 3. 30 is a yes for 2 and a yes for 3, so that means that it is also divisible by 6. All right, let's look at number 10. another 0, so I know 2 is a definite yes. Let me add my digits together. 1 plus 0 is 1, but 1 is not evenly divisible by 3. That would give me a fraction. So this would be no for 3. And since 2 is yes, but 3 is no, then 10 is not evenly divisible by 6. Our last example for this one is the number 24. 24 ends with a 4, and looking back at my 2 rule, if the last digit is a 0, 2, 4, that means it is divisible by 2. Let's check 3. The sum of the digits has to be divisible by 3. 2 plus 4 is 6, and 6 is divisible by 3. So since I know that 24 is divisible by 2, and it's divisible by 3, I also know that it is divisible by 6. For this chart, we're going to color in green. And that's the last one for this table. Only 2 to go. The next number we're going to talk about is 9, and it is the same rule as 3. You do the same action, which is adding your digits, but then the answer has to be divisible by 9. So we're going to make a table just like we did for 3, where we have the number sign, we have sum of dig for digits, and then our checkbox for yes or no. The first number we're going to look at is 432. Sorry about that, I wrote it in the wrong place, so we'll stick us some little plus signs right here. My digits are 4, 3, and 2, so we're going to do 4 plus 3 plus 2. 4 plus 3 is 7, plus 2 more would give us 9. Is 9 divisible by 9? Yes, it goes in one time. So that will give me a check for 432. That tells me I can divide 432 by 9. The next number is 76. It has 2 digits, 7 and 6. So we're going to do 7 plus 6 equals, I know 6 plus 6 is 12. So 7 plus 6 would be one more, which is 13. And does 13 divide evenly by 9? No, it doesn't. So that means that 76 is also not divisible by 9. The last example will be 873. I have 3 digits in this number, 8, 7, and 3. So I'll be adding all of those up. 8 plus 7 plus 3. I know that 7 plus 3 is 10. I always try to make a 10 if I can. And 10 plus 8 is 18. So 18 is one I know really well, that 2 times 9 is 18, which means 18 divided by 9 is 2. So since 18 is divisible by 9, then so is 873. For this table, we're going to use our blue. And start with 9 because it's the first one in my multiples of 9. that's the last one in my table for 9s, and we're down to our last divisibility rule. Oops, the camera cut off on us, but I'll just review quickly the rule for divisible by 10. For something to be divisible by 10, the last digit, it has to be 0. So 700 would be divisible by 10 because it ends in a 0. And every year when I ask for examples, somebody says 1 million. So I went ahead and put in 1 million because it ends in a 0. It is also divisible by 10. An example of something that's not divisible by 10 would be 746. Because this last digit is not 0, it is not divisible by 10. And I colored in all of my numbers in the 10 column with purple. Now let's put these rules to practice. Now we're going to practice these divisibility rules that we've talked about. And the first thing we're going to do is underline the last digit in each number. So I'm going to underline the 7 in 27, the 6 in 126, the 5, 8, 4, 8, 6, and 0. And I'm also going to go ahead and do the sum of my digits to help when I get to the 3 column and when I get to the 9 column. 27 has 2 digits, so 2 plus 7 equals 9. 126 has 3 digits, 1 plus 2 plus 6. 6 plus 2 is 8, plus 1 more is 9. 245 has 2, 4, and 5. 5 plus 4 is 9, plus 2 is 10, 11. 88, 8 plus 8 equals 16. 104 is 1 plus 0 plus 4, which equals 5. 438 is 4 plus 3 plus 8. 4 plus 3 is 7, and 7 plus 8 is 15. 296, 2 plus 9 plus 6. All right, 9 plus 6 is 15, plus 2 more is 16, 17. And 99 plus 0 equals 9. Remember, we're going to use this column when we decide about divisibility by 3, divisibility by 9. The first column are the 2's. We're going to go down the entire column and decide if these numbers are divisible by 2. We don't need the sum of the digits numbers right now, right? What we're looking at is the last digit of each number. I'm going to do this in red since I did my divisibility rules in red for 2 to tie it together. So I just colored the outside of my 2 red, and I'm going to use my red color pencil to make a check if it is divisible by that number and an X if it's not. Looking at the number 27, the rule for 2 is that the last digit must be a 0, 2, 4, 6, or an 8. This is none of those. That means 27 is not divisible by 2. 126 ends in a 6, so that makes it divisible by 2. So I put a check because this is divisible by 2. 245, the last digit is not a 0, 2, 4, 6, or 8, so that means 245 is not divisible by 2. Remember, this whole column is about the 2's. 88, the last digit is 8, so that is a yes, it is divisible by 2. 104 ends in a 4, so that is a yes. 438, that 8 makes it an even number, so that's a yes. 296 ends with a 6, and again it's 0, 2, 4, 6, or 8, so 6 is good. And 90 ends in a 0, which makes it an even number. Now we're going to skip over into our 5's, because that's another one that does the last digit of a number. So we're going to focus on this one next. And the divisibility rule for 5's is that our last digit in our number has to either be a 0 or a 5. The last digit in this one is not a 0 or a 5, so it gets an X. 126, not a 0 or a 5 in that last spot. 245, yes, we have a 5 here, so that means that's our first yes in the 5 column. 88 ends in an 8, so that's a no, that's not a 0 or a 5 at the end. 104, not a 0 or a 5. 438, not divisible by 5. 296, also not divisible by 5. That last digit would have to be a 0 or a 5. Now 90 has a 0, which means that is a yes for 5. That is divisible evenly by 5. And now I'm going to skip all the way to the tens, because that's the last one where we have to look at that last digit. I'm going to use my purple one to match the purple divisibility rule in my notes. The 10 divisibility rule, which I also use purple on. And for 10, the last digit has to be a 0. This one's a 7, so that's a no. A 6, no. A 5, no. An 8, no. A 4, no. 8, no. 6, no. But here we do have a 0, so that means 90 is divisible by 10. Now we're going to switch over to looking at the sum of the digits. In this first number, 27, when I added up my digits, I got a sum of 9. So I have to ask myself, is 9 divisible by 3? And it is, so I'm going to put a check. If I'm not sure, I can skip count by 3s, or I can go back and look at the numbers I colored in the chart. And just like we did on the other ones, I'm going to go ahead and color in around the box that matches the divisibility rule or the color we used with our notes. So we have an orange 3 here, and we've checked off 27. 126 had a sum of 9 from its digits, which we just said is divisible by 3. 245, the sum of the digits is 11, so that is a no. 88, the sum of the digits is 16, that is not divisible by 3. I think I might have said 11 divisible by 9, but I meant 3 since I'm in the 3 column. So 11 is not divisible by 3. 16 is also not divisible by 3. 5 is not divisible by 3. For 438, the sum of my digits was 15. And I know that 3 times 5 is 15, so that means that 15 is divisible by 3, which means the whole number 438 is also divisible by 3. 296 had a sum of 17, which is not divisible by 3. And 90 had a sum of 0, which is divisible by 3. All right, 6 is next. Actually, let's go ahead and do the 9 first, because that's the other sum of the digits. We're using blue on 9 because that's what we used in the notes. Make my little box around the 9. And then again, focusing just on the sums of the digits. Here, 9 is divisible by 9, so that would get a check. 27 is divisible by 9. For 126, the sum was 9, so 126 is also divisible by 9. For 245, the sum was 11. That is not evenly divisible by 9, so it gets an X. For 88, the sum of the digits was 16. That is not divisible by 9, so it gets an X as well. For 104, the sum was 5, which is not divisible by 9. 438, the sum was 15, also not divisible by 9. 296, the sum of the digits was 17. That is not divisible by 9. And last but not least, 9 plus 0 was 9, which makes 90 divisible by 9. So 3 and 9 have very similar rules. It's all about the sum of the digits when you add them up. Last but not least is 6. And if you've already done the 2s and 3s, 6 is very easy. The divisibility rule for 6 is that it must be divisible by 2 and by 3 to be divisible by 6. So that has to be a yes for 2 and a yes for 3. Looking at 27, It is not divisible by 2, but it is divisible by 3. They both have to be a yes, so since this number is not divisible by 6. 126 is divisible by 2 and 3, so 2 yeses means that we can divide that number evenly by 6. So 126 is divisible by 6. The 245 is a no for 2 and a no for 3, so it's definitely a no for 6. 88 is a yes for 2, but a no for 3, so that means no for 6. They both have to be a yes to be divisible by 6. 104 is divisible by 2, but not 3, so that means no for 6. 438 is a yes for 2 and a yes for 3, so that means that it is divisible by 6. Only 2 to go. 296 is divisible by 2, but not by 3. Since we don't have 2 yeses, that makes this no. 296 is not divisible by 6. 90 is our last number. It is divisible by 2 and by 3, so that means it is divisible by 6. We've got to have 2 yeses on 2 and 3 to be able to say yes to 6.